It's no secret that Elon Musk and NASA have proposed developing a fuel-free engine that can move at 99% of the speed of light. It may sound ridiculous, but NASA scientists have been working on an engine that may now be capable of defying physics. But what are their plans for these engines? What will it use as fuel if it can't use a propellant? Is it intended to be utilized for human travel? Is it possible to go to another planet in a short period of time? Could a Star Wars type lightspeed engine soon be a reality? These are the questions that you might be thinking about right now. So in today's video, we'll uncover the answers to these questions. Make sure you don't miss anything and subscribe and click the notification bell if you haven't already. Let's get started. Humans have aspired to transcend the enormous cosmic divides that separate us from the ultimate extraterrestrial destinations. However, even with NASA's Juno mission, which broke the world record for the fastest human-built spacecraft by flying at 74 kilometers per second, traveling to reach the closest star would still take us over 4,000 years. Considering this, we can see that our human desire to explore and investigate everything in space is causing us difficulties. It is, after all, space. It's too broad. Even if we flew at the fastest conceivable speed, reaching our closest star would still take years. Elon Musk's private space travel firm, SpaceX, was founded to increase multi-planetary life. In the event of a tragedy on Earth, he believes that transporting us to other worlds, such as Mars, could save us. In 2016, he predicted that history would only take two paths. One option is that humans will continue to exist on our planet until we are extinct. The alternative is to grow into a space-traveling culture and become a multi-planetary species, as he hopes we will agree. This is the ideal path to take, given that Elon Musk has expressed his desire to develop settlements on Mars on several occasions. But the existing limits of our technology and physical laws remain the two main limitations of spaceflight. On the other hand, another human urge is to find answers to significant problems. NASA engineer David Burns has been doing just that in his spare time. He developed a fuel-free engine capable of reaching 99% of the speed of light. He calls it the helical engine and puts it on NASA's technical report server. On paper, it works by exploiting the way mass can alter at relativistic speeds near the speed of light in a vacuum. This report has piqued people's interest in the same manner that the EM drive's early days attracted the public's curiosity. That engine has been speculated to violate physics. To put things in context, NASA's first attempt at developing a lightweight and fast engine was the EM drive. So what is the EM drive exactly? The EM drive is a radio frequency resonant cavity thruster invented in 2001 by Roger Scheuer, a British electrical engineer with 48 years of experience in the space and defense industries. Despite the law of conservation of momentum and other fundamental laws, internally reflecting microwaves are expected to generate thrust. The media has called the device the impossible drive. Theoretical hypotheses for how the EM drive might function go further than what is now understood about physics. It might be entirely new physics, as evidenced by the EM drive testing. Yet, there is no approved design for this device, and no one who claims to have designed it has committed to defining how it would work as a thruster. Nonetheless, according to NASA's Advanced Propulsion Physics Laboratory, one of these tests yielded a small apparent thrust in 2016. The thrust observed was later proved to be a measuring error caused by the Earth's magnetic field interactions. In March 2021, scientists from Dresden's Technical University published 3 papers suggesting that the push was a pure accident caused by extraneous influences. Despite receiving skepticism from some laboratory quarters, Burns feels that it is still worth pursuing. "I'm confident in putting it out there," he says. "I'll be the first to admit that even if it doesn't work, it was worth the try." To illustrate his point, Burns demonstrates a box with a weight inside, hung on a line with a spring at either end, bouncing the weight back and forth. This would shake the entire box in a vacuum with the significance of remaining stationary. The box would squirm in the same place overall. However, if the weight's mass grew in only one direction, it would provide a suppression resulting in thrust. What do the laws of physics have to say about it? According to the concept of momentum conservation, a system's momentum remains constant in the absence of external forces. Objects gain mass when they approach the speed of light, according to Einstein's relativity theory, which must be taken into account in particle accelerators. In reality, a simplified version of Burns' idea would substitute a circular particle accelerator for the ring, with ions being abruptly accelerated to relativistic speeds during one stroke and de-accelerated during the other. However, instead of employing the box and rod, Burns argues that a particular accelerator should be utilized for both lateral and circular motion, with the accelerator being shaped like a helix. In this scenario, however, there is a relativity error. If the weight is replaced with ions, the ions may be able to flow quicker at one end and slower at the other. According to special relativity, Burns' drive, on the other hand, is not a single closed loop. It's helical, like a stretched out spring helical engine. Before adjusting their velocity to change their mass, the engine accelerates ions in a circle to relativistic speeds. The engine then generates thrust by pushing ions back and forth in the direction of flight. The engine, according to Burns, has no moving parts other than ions in a vacuum trapped inside electric and magnetic fields. According to experts, the volute chamber would have to be enormous. To produce 1 Newton of thrust, 165 megawatts of energy would be required. It is 200 meters long, or 656 feet, and 12 meters in diameter, or 40 feet. That is the force required to accelerate a kilogram of mass per second squared at a rate similar to the power plant's production. The helical engine, according to physicists at the Technical University of Dresden who tested the EM drive, will most certainly suffer from the same problem. One of them argues that no inertial propulsion system has ever operated in a friction-free environment. However, according to Burns, the bulk of the energy lost by the accelerator due to heat and radiation can be recovered. He also suggests ways to keep momentum, such as using the spin of pushed ions. Coming up with something unique and effective is indeed tricky. As you can see, science is still in a state of flux. Thus, our pessimism is probably justified, but don't be fooled. Given how quickly aerospace innovation advances, we shouldn't be surprised if a competent faster-than-light engine appears in the future. And once that happens, all of our science fiction fantasies will be on their way to becoming scientific fact. What are your views on Elon Musk's and NASA's near light speed engine that defies physics laws? We'd like to know in the comment section below. Thank you for watching and stay tuned for more futuristic science videos like this in the future. See you next time!